monster robots and monster welds.
The weld joints for this truck are stronger than the casting.
A river of metal and a backbone of steel.
It's pretty awe-inspiring to be working on something that's this large.
It is an earth-shattering design on a groundbreaking scale.
Even though we build them tough, they get used tough.
A mining marvel, manufactured at the Mégafactories of Caterpillar. It's one of the world's largest dumper trucks, hard at work on the oil sands in Alberta, Canada. It is the 797B, and everything about it is huge. It is more than 7 meters tall. And when loaded, it weighs nearly 600 tons, more than a Boeing 747. And it's powerful enough to move mountains. It's got a giant dual engine that delivers over 3,500 horsepower. That's twice as powerful as an M1 tank. Creating this truck is a job as big as its payload. To build this beast, costing more than 3.4 million euros, it takes Mégafactories, including 6 huge facilities across North America. The engine is created in Lafayette, Indiana. The 5-ton tires are manufactured in Lexington, South Carolina. The state-of-the-art cab comes to life in Joliet, Illinois, and the 45-ton dump box is assembled in Canada. But to join up the huge frame and most of the components, it takes Caterpillar's Mégafactory in Decatur, Illinois. This huge vehicle is too large to ship to any customer in one piece. To assemble the more than 600 tons of individual parts, it takes 20 non-stop days, and it happens on-site where the monster machine gets put to work. Places like Fort McMurray in Canada near the sprawling Alberta oil sands. And before the build, it all starts in Amite, Louisiana, a mecca for molten metal known as the Amite Foundry and Machine Company, where they cast the phenomenal frame.
In the state of Louisiana, we make gumbo, we also make metal.
The 797B's frame is the backbone of the truck, the essential building block that holds the mega machine together and carries its enormous weight. The frame is made up of 9 separate castings. It stretches over 11 meters long and weighs nearly 28,000 kilos. At the foundry, the crew is making the center casting, the frame piece that supports the truck's huge payload. It begins with molten metal, and this is the star of the show, a 45-ton metal melting oven called an arc furnace. The crew fills the furnace with scrap metal. Operators lower 3 highly charged electrodes into the chamber. When the electrodes touch metal, they create a scorching 2,200-degree electric arc. The heated metal bubbles, then melts. 2.5 noisy hours later, this liquid metal is ready to pour. And that calls for the ladle crew. The crew uses a manned crane to guide the empty 9-ton ladle to the waiting furnace. Out pours a fiery river of 1,650-degree metal, hotter than a volcano. Now for the tricky part, guiding the ladle to the parts mold. Inside this mold, there is a cavity in the shape of the final frame piece. The crew positions the ladle above the pour entrance, making sure to stay back from the scorching heat. Molten metal fills the cavity in a fiery flash. The steel-filled molds have to cool for 36 hours. Once cool, the molds come off. At this point, the casting looks rough, with coarse metal nubs sticking out from it. To get an even finish, crews cut off the excess steel.
All the excess gets cut off. Okay, this, cut here. That gets cut down low.
It is sweltering work. Once the foundries finish the 797B frame pieces, they're shipped off for assembly at the Caterpillar factory in Decatur, Illinois. But first, to see the load-carrying might of this dumper truck in action, it takes a trip to the oil sands of Alberta, Canada. Here, they do not drill for oil, they dig for it. The oil, called bitumen, is trapped in the sand rather than in oil pockets under the ground. The 797B dumper truck is critical to the mining operation. Each day, these extreme machines move nearly 275,000 tons of ore from the mine site to oil processing plants, where skilled workers use crushing combines, hot water and engine-powered refiners to separate the oil from the sand. Eventually, this crude oil becomes petrol, kerosene and jet fuel. But before they can haul the huge loads, these monster machines have to be built at the Mégafactory in Illinois. With 28 buildings covering over 140 hectares, it is one of the top mining and construction equipment facilities in the world, and the manufacturing hub of one of the world's largest dumper trucks, the 797B. Our dumper truck's 9 steel frame pieces have arrived from outside foundries. They are ready for the next steps, machining and welding. Here in Building D, workers prep the metal joints for a super smooth weld.
This rear casting section would come in rough from our supplier, and one of the things we do here at Decatur Caterpillar is we'll machine these surfaces. When we assemble or weld the truck, we machine these casting surfaces in order for a very tight control of these joints, providing a very good weld joint.
The dumper truck frame pieces join together in 3 main stations. The robotic welding area, where machines fuse the main frame together. The checkout station, where the final welding steps are completed. And the area where it all begins, the tack fixture station. Right now, the initial weld is underway. Randy Shorey and his team are putting each frame into a jig, a huge vise that holds them in place.
We're taking all the parts and making the basic frame of what's going to eventually be the 797 truck.
These parts range in weight from over 200 kilograms to more than 5 tons for a single part. Moving them is a massive job. Randy needs help from the remote-controlled crane, but first he must position the chain carefully to pick up each piece. One mistake could cause a colossal crash.
Yeah, you got to get everything just lined up just right. You got to have your chain centered up, and then when you pick it up, you got to be careful so that it doesn't fall over one way or the other. It's leaning a little bit too far the one way, but it's close enough that I'll be able to set it in the fixture.
To ensure a strong weld, Randy has to line up the pieces perfectly in the jig, with only a tiny gap between the seams.
Well, I've just set this part in. Now we're going to take all these here bars and tighten everything up and get it in position. We'll start welding right down here and bring this up and weld it all the way around here and down over to this other side. One of these here probably takes on average 3 or 4 hours, depending on how fast you weld.
Randy and his team must tackle an impressive 18 welds in total. This giant Caterpillar frame is starting to come together. but the welding is not over yet. Before the frame can shoulder the load of a 797B dumper truck, it has a date with some super-sized welding machinery that takes this assembly process to high-tech heights. For more than 80 years, Caterpillar's yellow iron has transformed the world. No one on Earth makes more construction vehicles. 200 different types of machinery at work in nearly 200 countries. The story began at the turn of the 20th century in the California farmlands. Inventors were in a race to replace horse-drawn farm equipment with new steam engine power. The first prototypes were so heavy they sank, but in 1904, inventor and entrepreneur Benjamin Holt came up with an ingenious solution: tracks.
Replacing the rear wheels of his machines with sets of tracks. These tracks distributed the weight of the machine more evenly and allowed the machine to actually float across the field.
The revolutionary track design kept the machine moving, no matter what the terrain. A photographer saw one crawling across a field and called it a caterpillar. The name stuck, and in 1910 it became a Holt trademark. Then in 1925, the Holt organization joined forces with farming manufacturer C.L. Best, and the Caterpillar Tractor Company took off. Today, these massive machines surpass anything Caterpillar's founders could have imagined. At the Mégafactory in Illinois, this trained team is already hard at work building the support structure of the dumper truck, a towering steel frame weighing 27 tons. It's strong, flexible, and built to last for more than 2 decades.
We like to refer to it as the backbone of the machine. That essentially is the component of the truck that's going to carry the reliability. We would change out engines, we change out suspension components, etc. But the frame, for the most part, stays around for the entire life of the truck.
You're going to be hitting ruts, you're going to be hitting essentially very large potholes. So the frame must flex in order to take up the bumps in the road.
So far, Randy Shorey and his crew have fused together the 9 foundry-crafted steel pieces into the precise shape of the frame. It is time for the next stage: robotic welding. This 21-axle robot welder is 7 meters high, one of the largest welding machines on Earth. It takes 9 computers to run it. 2 robotic heads tackle the frame's seams. A touch sensor calculates each weld seam's exact width and depth. It takes the machine more than 20 hours to fuse everything perfectly together. The next build station is called the rollover. Technicians tackle the hard-to-reach welds and any high-stress areas that need to be extra strong. This work demands the human touch.
Our eyes are a lot more sound than the ones of the robot.
Each frame uses an amazing 125 kilos of welding wire, a fast-melting metal joiner that works like hot glue. Welder Shannon Bale is working on structural supports called drop tubes.
The reason why this weld has to be so tough is because it's a very high stress area. It's always under an extreme amount of stress because on each end of this tube, we have 2 cylinders that raise and lower the bed of the truck.
Shannon is using special welding wire made of carbon steel that hardens fast to prevent drips. This speed freezing wire allows welders to work uphill without making a mess, but it is delicate work.
I would strike an arc here, and what I do is, if you could see this, I'd hold here, then I'd come over here like a Christmas tree, then I'd hold here, then I'd come up just a little bit more, then I'd hold here for a little bit. That way we're tying these sides in together. And then just keep on working your way up When I first got over here, this is the job I wanted to do because this is so neat.
At last, the frame assembly's colossal task is finished. All 9 pieces have been welded together. But before this build can go any further, this frame gets a tough inspection. A 797B's frame must be rock solid, or the whole truck could collapse. Technicians double-check critical seams with an ultrasonic flaw detector. It is a lot like the ultrasound used to monitor babies in the womb. Ultrasound technology works in a similar way to sonar. The tool emits high-frequency sound waves through a special conductor gel. An attached computer detects and converts the sound waves based on how they bounce back, generating colored images that reflect strength and weld density. Justin James is in charge. He takes 3 hours checking every frame.
Like right now it's light blue, which isn't very bad. Now if you see red or yellow, then that means that we're going to have a problem.
In this case, the welds are good. Next up, painting. Today, the paint booth team's working on a giant earth-raking machine called a motor grader. Every Caterpillar vehicle gets a 2 or 3 millimeter coat of durable trademark yellow paint. And this is no ordinary paint job, using a method called an electrostatic paint process. A specially designed spray gun gives the paint a negative electrical charge, while a supporting track gives the tractor part a positive charge. When the yellow spray flows, the negative paint attracts to the positive steel. Here on Alberta's oil sands, oil is everywhere, trapped in the sand. It takes off-site refineries to separate the oil from each grain. But underfoot, this oily, sandy mixture makes the ground soft, sticky, and abrasive. Tough conditions for the 797B, and even tougher conditions for the world's biggest tire. Towering over 4 meters high and weighing 5 tons, each giant XDR tire is as tall as a single-story building and sports enough rubber to tread 500 cars. And they're expensive, anywhere from 35 to 65,000 euros apiece. Each 797B dumper truck needs 6 tires in total, 2 up front and 4 at the rear. These supersized tires begin life thousands of miles away at the Michelin tire factory in South Carolina. These monsters are built in several stages. First, the raw rubber goes through a machine called a plastifier, where it is ground up into gooey pellets. The pellets then travel to the mill, where another mega machine called an extruder stretches the soft pellets to create a thin rubber layer.
At the mill, the rubber is flattened so we can cut it and make it into bands where we can feed it over into our extruder.
The massive rubber sheets are spray-cooled and then dry off. Workers roll them into a circle, but to become a true tire, this rolled rubber needs painstaking personal attention. At the hand assembly area, workers hand form every tire. As the team smooths and aligns them, the sticky rubber sheets naturally adhere to one another. It takes up to 130 rubber layers to form the tire's main surface.
As I'm laying it, use my hands to make sure that it stays on that laser and that it has the right amount of tension applied. All the products are laid evenly all the way across and roll down the joint to release any air that may be trapped.
Technicians then insert a layer of rubber-wrapped steel to give the tyre strength and durability. The bigger the machine, the more steel layers these tyres need. A large earth movers tyre may use as many as 6 steel layers, called belts. Technicians place these huge rubber rolls into a top-secret mould. Here, pressure and heat force the rubber to take on the tread pattern that makes these tyres the strongest in the world. 12 hours later, the finished tyre emerges. These tough treads are now ready to stand up to the worst conditions the Alberta oil sands can dish out. And out here on the job, these mega vehicles have to run 24 hours a day, 365 days a year. The secret to their success is a 3,550 horsepower engine. To get to this towering dumper truck's engine, you have to climb a flight of stairs. The 19-ton engine fits deep in the dumper truck's belly. This helps give this giant a low center of gravity, keeping it stable on rugged terrain. But to see the creation of this monster diesel-burning power plant, you have to travel all the way to Lafayette, Indiana, to the 140,000 square meter birthplace of the 797B's engine.
There's no greater feeling of power than building a 3500 engine.
This is a massive machine. For sheer power, it would take 7 Ferrari F430 engines to match it. And it weighs more than 19 tons.
Max of what you see in your car, the little 8-cylinder engines. And here we have 24, and not only that, they're really big. So it's pretty awe-inspiring to be working on something that's this large.
These 24 cylinders add up to major horsepower. Horsepower measures the maximum power output of an engine. The bigger and heavier the vehicle, the more horsepower it needs. The trick to building an engine strong enough to drive this huge dumper truck is to fuse 2 engines together into one. To craft the unique double engine, every step of the build happens twice. When it is all put together, the 797B's diesel power plant turns into the largest truck engine in history.
When we needed 3,550 horsepower for this 400-ton truck, we had available to us about half that much horsepower in one 3512 engine. So what you see here is one 3512 engine, another 3512 engine. We made a mechanical connection between the two, and we made an electrical connection between the two. And what you see here is a finished product, one monster 3,550 horsepower engine. We call that a 3524.
Like most diesel engines, the fundamentals are similar, only supersized. Inside the cylinders, pistons attached to connecting rods compress air. The pressure causes the air to heat up. Fuel then injects and combusts, forcing the pistons down and turning the crankshaft. The crankshaft transmits the energy through a set of gears that ultimately drive the wheels. The connecting rods are one of the engine's most important components. They attach the pistons to the crankshaft. Each of these strong steel connecting rods is 3 times longer than those in a typical pickup truck. The pre-made connecting rods come to the factory in rough form. Workers machine grind and smooth them to a precise size and weight. Leave any rough spots and the entire engine could break down later on. Constructing the 797B dumper truck is a huge operation. The engine crankshaft is next. Inside a working engine, this 500-kilogram giant rotates nearly 2,000 times a minute. It must be perfectly formed and smoothed down, or it could break the engine apart. Team leader Troy Brown uses a hoist to lower the rough crankshaft into place. To get a perfect finish, the team uses a stone grinding wheel called a pin grinder. The pin grinder positions the crankshaft against the stone. As it speeds up, crankshaft and stone make contact. Sparks fly, even with a liquid coolant. The grinding stops only when every surface is perfect.
Because it is an internal engine component and has to be precise, it is the heart of the engine.
Next is the engine block. This slab of metal houses all the engine's critical components. The technicians machine the sides and bottom and bore holes for wiring, fuel and moving parts.
When the doors close, you'll see the coolant kick on and the spindle will start turning and we'll start generating a hole. So that's what makes this solution unique, in that we have a very accurate machine tool and that's capable of working a very large component.
Once perfectly machined, the connecting rod, crankshaft and engine block all come together in an area called the engine assembly short line.
From this point, we'll inspect it from end to end, checking for any damage or anything that we don't want to. We'll load it up into the engine block right there behind me.
Technicians lubricate, hoist and secure the crankshaft into the engine block. Next, the pistons meet the connecting rods. These piston powerhouses are far heavier than those in a standard truck, and to attach a piston this massive, you need a piston stuffing robot.
This is connecting rod, this is the piston, okay? And then this connects to the crankshaft in the middle of the engine, and then they'll be bolted on and torqued down.
The engine's internal parts are safely installed at last. It's time for this diesel giant to travel down the line and get some personality. First, heads and rockers. During combustion, the rockers open the valves within the engine cylinders to let in air and fuel. Without rockers, an engine grinds to a halt. Workers use a high-tech machine called the 10 spindle to torque or tighten the bolts.
The 10 spindle is pretty cool because just one little push of the button and it's real easy.
Next, technicians install aftercoolers, fluid lines, and finally, the wiring groups. At last, after multiple painstaking steps and build teams, the engine's complete. It's ready to leave the factory and to meet up with its frame. Back at Caterpillar's 797B assembly headquarters in Decatur, Illinois, the engine has just arrived from Lafayette, ready to take its place inside the finished frame. Teams install the engine's hydraulics and wiring system. A crew then hooks the engine to a 55-ton remote-controlled crane. With parts this size, assembly is a big challenge, and in this case, it is also a tight squeeze.
The compartment's only so big, so it's like putting on a glove. You only have so much room.
The team carefully guides the 20-ton engine into the gap in the frame. Bolts lock it firmly into place. This giant vehicle is starting to take shape. But to get this machine road ready, it takes 2 skilled workers with safety straps and a remote control. They carefully guide the more than 40-ton beast onto the flatbed delivery truck.
You have to really be in tune with the guy that's beside you. Any off balance can make the straps break or you shift the truck from one end to the other. The first time you pick the truck up, you're really nervous.
The Caterpillar's 797B's frame and engine are now ready to hit the road. But to become a mega dumper truck, there are still 2 major hurdles left: final delivery and final assembly. And it all happens almost 3,000 kilometers away in Alberta, Canada. It is gritty and grainy, and it is one of the toughest environments on Earth, the oil sands of Alberta, Canada. Here, dumper truck drivers like Paula Freak spend 12 hours a day hauling ore from the pits, transporting it to oil separating and refining plants. The truck cab is their office and command center. To keep fatigue at bay, everything in the 797B cab is ergonomically designed, from panoramic view windows to hydraulic adjustable seats to control panels with user-friendly icons. Everything in here puts creature comforts up front.
We have a good HVAC system in here that keeps them cool or warm and ergonomically seated so that they don't get tired. Because if they lose control of this equipment or their attention is lax, there could be serious consequences.
Building these colossal cabs starts here, the Bergstrom factory in Joliet, Illinois. It takes a single dedicated technician about 40 man-hours to construct the entire cab from start to finish. Today, master assembler Brad Hill is training new recruit John Chambly.
Overwhelmed, I was kind of like, is this really one person's job? Does one person really got to have this done in a certain amount?
First up is the cab seat. Getting this installation just right is critical to driver safety. The team maneuvers the seat through the door and secures it to the floor. Brad tightens the bolts by hand. Next, they attach special hoses that feed compressed air into the chamber. The air chamber hydraulically adjusts the seat height. The result? Perfect driver alignment. John tries his hand installing the cab's panoramic window. Each specially designed windscreen offers the widest possible sight lines of the whole road. Prime visibility that helps keep operators safe and in control. The cab is even equipped with built-in sound barriers to protect the driver's hearing over the long haul. At last, after several days of painstaking build steps, this dump truck command central is ready to take its place at the helm of a monster machine. Back on the oil sands, shovel operators scoop hundreds of tons of sand into the dipper and drop them into the 797B dumper truck. And to handle this mountain of ore, Caterpillar designers gave this 797B the ultimate dump box. Nearly 10 meters long and made from solid steel, this enormous box is so big it can hold 100 cars. And it is assembled here at the Leo Roberts fabrication facility in Fort McMurray, Canada. Trained assembly teams craft one of these monster boxes a day. The 797B box is made up of 5 prefabricated pieces: the floor, 2 side sections, the front wall, and the canopy. Welder Preston Shiner hooks up the center floor section to the crane. He joins it with the other pieces for bolting and welding and moves it to the work area. Once airborne, this 15-ton metal slab becomes a handful. The only means of control is a piece of rope that stops the floor from swinging as it lines up with the cart. The floor must be carefully placed on the cart or everything could tip dangerously. Crane operator Victor Major guides the first sidewall section to the cart. He maneuvers it carefully into place. To bolt the floor and sidewall pieces together, builders use a tool called an impact wrench. The impact wrench uses air compression to increase the tightness of each turn. But there is a problem. Even with securing bolts in place, the sidewall and the floor will not line up. A piece of metal is in the way. The solution is to cut it out with an oxyacetylene torch. The torch mixes the oxygen with acetylene, which is highly flammable. It creates an extremely high temperature flame, burning at over 3,000 degrees. It cuts through metal like butter. With the first side section of the dump box secured, Preston maneuvers the second wall into place. The team bolts the floor and wall together. It's a solid fit. Now for the final piece, the front wall. The team uses a crane to grab and hoist the wall into position. But there is another glitch. The box is slanted. To line the wall up, the team has to pull the bottom in. A crew member cuts a hole in the base of the wall and attaches a winch and chain, slowly pulling the wall into place. A welder now attaches bolt fixtures to the front and two side walls and pulls them together using an impact wrench. The last task is to tack weld the front and side walls together. This stops any slippage between the three pieces during the final welding. At last, the giant 797B box is complete. But to make sure it can stand up to some of the heaviest loads in hauling, welders have one last job. Over the next 7 to 10 days, technicians fuse every joint and seam until these assembled parts can brave the rigors of the oil sands. 100-kilo transmission. This job calls for a heavy-duty crane. The challenge is to make sure the sling holding the transmission is strong enough to handle the weight without collapsing.
If we weren't to use the correct lifting devices up here, we could easily overextend the sling and break it, or we could drop something heavy and, worst case scenario, hurt somebody.
To measure and monitor the sling, engineers designed an ingenious safety feature called a tattletale. The synthetic fiber tattletale's loose strands hang down from an empty sling. As the stretched sling takes on a heavy load, the tail retracts. Technicians watch for the tattletale at all times. It tells them if the sling is stretched too far.
If this is no longer visible, then that's the indication for us that something has been done that's not right with the sling. We take it out of service.
Now the stakes get even higher. The team has to fit the transmission into a space not much larger than the part itself. One wrong move and another part of the truck could take a damaging hit.
It's a very tight fit, and we're dealing with such heavy weights. It's very important not to let it touch anything.
The team installs the transmission with pinpoint precision. Mechanic Tom Chase's next job is to hoist the 4-meter, 5-ton tires into place. These steel-belted rubber giants bolt to the axle with some serious hardware.
Your typical automobile would have 5 or 6 wheel nuts torqued to approximately 75 to 100 foot-pounds. This one's got 47 nuts and they're torqued to 2,300 foot-pounds.
And a giant tire needs a giant tool, the air-operated torque wrench.
This is one of the more physical jobs that we do. Well, I try to support the machine as close as I can to my body. The farther out that you hold it, of course, the heavier it gets. So I try and cradle it in my arms and support it that way, so got to keep it close and it's not quite so heavy that way.
With the wheels in place, it is time for rubber and ground to meet at last. The team lowers the truck off the assembly risers using 4 hydraulic jacks. This machine is ready to make its final journey to the mine site. nearly 25 kilometers away. But these vehicles are too heavy and too wide to travel on ordinary roads. And that calls for this beast, a wheeled trailer more than 40 meters long. The transport team positions the trailer under the truck. They put wooden blocks beneath the front and rear axles. These blocks support the truck's weight and keep it stable during the journey. Once the team secures the dumper truck in place, the trailer slowly moves out. It is on its way. It takes 1.5 hours to travel from the workshop to the mine site. Here the team offloads the truck. But this monster needs its last critical part. It is time to head to the workshop for the final assembly process, attaching the box. Getting the dump box ready to attach to the truck is a tough challenge. Mechanic Nelson Matachuk begins by connecting strong synthetic fiber slings to the box using a 22-kilogram shackle. Before it can fit into place on the dumper truck, it takes 4 slings and 2 cranes to lift the 45-ton box. Nelson maneuvers the first crane into position. He then connects the sling to the box.
Okay, now we'll do the other side.
Once he's got all 4 slings connected, Nelson begins the lift. He operates both cranes simultaneously to keep the box level. Surprisingly, this treacherous task has to be a one-man job.
Well, it's easier for one person to do it than 2, because if you got 2 guys running the controls, one guy will be stopping, the other guy might be starting, and you end up getting the box swinging or something. This way, one guy's controlling the whole situation.
While Nelson lifts the dump box, a driver moves our 797B out of the adjacent bay and reverses the huge vehicle beneath the dangling part. Nelson slowly begins to lower the crane. Now for the tricky part. Nelson must lower this giant, swinging 45-ton box onto 2 pin supports.
It's not even a few inches. There's only a matter of, I don't know, there might be a half an inch on each ear there. That's it, once the box is sitting there.
It is all a matter of timing. Nelson waits until the 2 parts are aligned and then carefully lowers the box. The box is in. The team now anchors the dump box in 3 places: at the rear pin supports, the hoist cylinders, and on 2 front pedestals. They start with the rear pin supports. The first step is to jam a set of shims, 2 metal rings beneath the dump box and the pin supports. This stops any side-to-side movement during operation. The next step takes muscle, hammering the pins in place.
Good job, guys. Good job.
To finish the job, the team tackles the pins that connect the hydraulic hoists to the dump body. Mechanic Douglas Novice starts the 797B engine. He raises the hydraulic cylinders, lining up the pinholes with the bottom of the dump box. He's going for a tight, secure fit. The same procedure repeats on the other side of the truck and the front pedestals. Nelson positions the pin into place. Finally, Nelson flexes the monster machine's muscles, raising the trunk bed. The dumper truck now has the ultimate part, assembled perfectly. It has taken 6 factories, over 600 tons of material, multiple teams, and about 80 days. At long last, this giant has come together. Armed and ready to do battle on this testing mine site.
Seeing what the product does, seeing it carry 400 tons at 40 miles per hour, that gives a great deal of pride.
The Caterpillar 797B dumper truck. A mega build from a mega factory.
There's another brand new episode of Megafactories at the same time next week. And Engineering Thursday continues after the break with megastructures.